Okay, so today, remember you have 5 different whirligigs with your group. And so in your data tables, remember you are measuring those 5. Distance across the top there is your wingspan. You are going to time them for 3 drops. But when you do that, one person just holds it. Basically, you want one person to do this every time. They need to drop it the same way every time. So just basically hold it over their head, and they drop it, and it goes down. If it goes straight down, now if it happens to just fall, because sometimes they don't start spinning, they just kind of tumble down, make a qualitative observation that just tumbled down that you're repeating that trial. If it goes off at an angle, you probably want to do that. Also, look at the data given. If you get like 2 seconds, 2 seconds, 8 seconds, does that 8 seconds sound reasonable, considering the other 2 were 2? You might want to repeat it, but if you repeat it, again, make a qualitative observation. Your trial came out 8 seconds, redone. Just say, it could be on your data table for 2.5 centimeter wingspan, trial number 2 was repeated twice to get the data. Little things that you're going to use when you make your lab report. So right now, this is all in your notes, right? This is where we left off last time in your notes. It should be, right? I'm not delusional. Been a few wake-ups, a few sleepless nights. So what I want you to do now is with your group, gather. We're going to take about 20 minutes. Gather your data. Once you finish gathering your data, you can take your whirligigs, put them in recycling, bring your kit back to the front. Don't worry about doing anything else, because then we have to go to the next step, which is analysis. And we don't just tag on things onto our data table. The only thing that goes in our data table is data. The things, the quantitative observations, the things we measure. Calculations go in a completely separate table. So once you gather your data, put your equipment away, and so I know that your group is done, and do something quietly until we all get done. Okay? Questions on what you're going to do for the next 20 minutes? All right. Gather your data, please. So we've conducted our experiment now. Conducted your experiment, so you have all that time data. But after you gather your data, you need to do analysis. Now in our lab reports, it's called calculations. But notice, if you take out the lab report form, what is written in parentheses next to the word calculations? 2 times, because it's worth double. Notice down in conclusion, it has 3x. It's worth triple. Triple and double what? Well, if you go to the back page of that, notice there is a rubric. Now, next time we meet, we will be actually going over your lab reports and going over the rubric and grading it and things like that. Basically, the lab report you write today, I give you credit that you wrote it. And we're going to go over it, and you're going to get another chance to rewrite it. Okay? So the rubric is a 4-point rubric. So the problem hypothesis section is 4 points. Observation is 4 points. Calculations would be 8 points. And then 12 points on the rubric for the conclusion. And we all write our own conclusion. Now the rubric, for the most part, is designed for detail. In other words, how much detail? Do you put this level of detail, that level of detail, and so on that. Calculations, yes, they can be wrong. Your graph can be wrong. That you can get some points off that. But if you use whatever calculation you use and you use that in your conclusion, you're not going to lose points because you used whatever you got as your conclusion. All right, you might lose points because, okay, you just did the calculation wrong. But because you got it wrong, you got this answer, and that's what you use to answer your conclusion, and that's fine. You go with the data. It's another thing about data. Because you have a hypothesis, you think which way it's going to go. If the data doesn't go where you think it's going, doesn't mean you're doing anything wrong. Remember, that's just where the data is going. Okay? So be careful. Sometimes you get preconceived notions and you think you're doing something wrong when it's just the data. Okay? We go where the data takes us. On that. But once we get that data, we have to do some analysis, which means calculations, our math work. And to be honest, this is where most of the math in this class comes. Most of the math that you're going to do in this class is going to be in labs. Math with a purpose. The graphs we do. We're going to take that information, make graphs. We do use a lot of graphs. They show trends and relationships. We have a graphing program that we use for the most part. There are a couple labs we graph by hand, but most of the graphs we do in the computer. But if we are making a graph, if I ask you to make a graph, it probably means that the answer for whatever the problem is going to come from the graph. We don't do graphs just for the sake of doing graphs. That's math. In science, we do graphs because we want a piece of information. It's going to show us a trend, how something's going. It's going to show us, more importantly, we look at relationships. Is this a directly proportional relationship? Is it an inverse relationship? Is it an inverse square relationship? And to be honest, inverse and inverse square on a handwritten graph look pretty much the same. Okay, but when you use the computer, you can see, go between the two and see which one works better for your data on that. Also, sometimes in sciences, we don't have numbers. We have just lots of qualitative observations. You might have to rearrange those. You're making lots of observations of something. You're watching, some squirrel in the tree. You have lots of observations. You might reorganize it into different things, depending on what your lab is. So now we need our analysis. Anybody need more time? So we always write our headings, so calculations. So, we have some time data. You took 3 trials of each one. When we take multiple trials, we're usually going to do a what? If I take multiple trials of the same piece of information, I'm probably going to take a average. Yes, very good. Take an average. So that's one of the things in our calculation table. We make a whole new table. We don't just tack it onto the observation table, because observation tables are for what you measure along the observation section. Calculation tables are where you put the answer to your math work. It's a totally separate table in a separate section. Now I do need to identify where that average time belongs to. And usually take whatever the first column was. In this case, our first column was wingspan. So you're just going to copy down the wingspan in centimeters. You're just going to copy down whatever you had in that. 1, 2, 3, 4. So you're just going to copy whatever you had in that column in the observations. Copy that down. Second column. Average time in seconds. All right. So right now, each group in that section, do your calculation. It will take about 5 minutes or so. Do the calculation. Since you have 3, you're going to do, how do we find the average? We're going to add them up and divide by 3. Okay, so let's everybody do that right now. Work with your group, and then we have something else to add to the calculations here afterwards, but let's get those calculations done. So this should be in your lab report. So this is for your lab report. So you can put the notes off the side, put this in the lab report. Yes, I'm going to leave that up. Pardon? I would just write out the word. Sometimes, like for average, a lot of times I'll use this AVG, average time average, whatever. But wingspan, you probably want to put the whole thing. I'm going to do your first one for you. Every time, you notice on your lab report form, in the calculation, the second little bullet says, one sample calculation in words, symbols, numbers, and solve with units for every different type of calculation. Now, although you did a calculation 5 times, you did the same calculation 5 times. So how many different types of calculations are in this lab? 1. There's only one type of calculation. You only have to show one sample. And we usually use, in that example, we put in numbers from your own data. You just choose one trial. With the caveat, there will be occasion when you may have no numbers. You still need to put in your sample calculation to just make up numbers for it. Because sometimes when we do things where you make something, your lab doesn't work, and that's okay. And you will get no data. But you still have to show the sample calculations, because these are the calculations you would have made if you had had some data. So you always need sample calculations whether you have data or not. Now, what I'm going to write down now does not belong in your lab. I'm just showing you, just so we know what we're doing. So it's words, symbols, numbers, and that comes from your lab, and solved. Okay. So, down there underneath you would write so right now underneath your table you're going to write sample calculations. You just write that word sample calculations. And the first sample calculation is average time. Now if you had several different ones, you would have that. Now, if you look at the sample, this is probably the sample has a couple errors. There are two samples on the sample lab of that. The one for acceleration has it in words but not symbols, whereas the one for average acceleration has symbols but no words. So that's a typo on that. So make sure all four of these are there. With units, you need to have the units. In other words, seconds, meters, whatever it is. So in words, we would say average time equals time 1 plus time 2 plus time 3 divided by 3. So what I put in red should be going in your lab report. What I'm putting down in red should be going in your lab report. Okay, this is right after the table. What is in red? So this is what I would expect to see for every single type of equation. We do it in symbols. T average. I usually use subscripts to tell you things, different things. This is average. AVG is what I usually use for average. Equals T1 plus T2 plus T3 over 3. Everybody understands what it means when I say subscript? Subscript means would be like a little number or letter that goes next to the symbol. That's a subscript on that. If it was up here, like if you're doing word processing, you want that, you highlight it, hit subscript. It makes that. Like if you want squared, it's called superscript. If it goes at the top, like a square sign with T squared, the squared when you type the thing is called a superscript because it goes above. Sub goes below, super goes above. Numbers. Now, in your lab, you want to pick, I'm going to just make up some numbers, but in your labs, you want to choose some number from your data that you know. You already know what the answer is, so just choose one. So T average, I'm just going to say 2 seconds plus 3 seconds plus 4 seconds divided by 3. So this would be numbers. So our next step would be numbers. You choose one of your steps. Choose just one trial, one of them. Doesn't matter which one. I'll just make you have data here. Then we just solve it. You already know what the answer is because you've already done it for your table. T average equals 3 seconds. And we box it or circle it to show that that's the final answer. Okay, note, but we have our units. That's very important. The 8 points on the rubric, if you forget to put units, you would lose one of those 8 points on the rubric score. Okay? And there are 28 points on the rubric. And that 28-point rubric score will be converted to a score out of 30 because all labs are worth 30 points. And when I convert it, I also shove some participation points too. Okay, so it doesn't come out exactly like a percentage on that. There are some participation points on that. All right. So everybody should have what's in red should be on your lab report. Should be in your lab report. All right. Anybody need a little more time to get it down? So the last part of a lab report, or a lab of our scientific method, is the conclusion. The conclusion. Once I've gathered my data, I have done my analysis, I look at everything, I get conclusion. Conclusion, we're going to write something. We're going to write something up. And we're going to talk about the data. We're going to talk about the calculations. We're going to talk about the graphs. We're going to talk about what happened. This is what you do in your lab reports. This is the first part of your lab report, is you're going to talk about the data on that. And notice, if you go to the back, and you look at the conclusion on the sample, you'll notice there are numbers in there. So you want to talk about the quantitative data. It's like what I went through. The time. The time stretched from this point to this point. Talk about your averages. Give the actual values. If it's a graph, you talk about the graph. Talk about any problems you had. Those qualitative observations that you're going to put into regular words. This is called the summary of the results. Once you do that, you talk about, was your hypothesis correct or incorrect? And give evidence. Maybe your hypothesis was the long wings, the hypothesis is stated. We never use pronouns. You never say I, he, she, Bob, whatever. We say, instead of saying I said the hypothesis was or my hypothesis was, we don't use that. We say the hypothesis stated that long wings would fall fastest. This hypothesis was, say, incorrect because short wings were faster, falling an average of 2 seconds versus 4 seconds for long wings. So you give a piece of evidence. Could be correct. What if your data was all over the place? In other words, the little one was highest, then it was really low, then it got big again, and low and big. It was kind of all over the place. Well, that could be inconclusive. In other words, it was inconclusive. No determination, in which case we would have to redo this lab. There was an error somewhere. But if you can't make any conclusion, inconclusive is an okay answer. The hypothesis was inconclusive. That means you couldn't tell whether it was correct or incorrect. But again, you have to explain why it was inconclusive. Okay? It's not so much that it was correct or incorrect. The most important here is why or why not is the most important part of this. This may take several sentences. Might have to talk about the graph and show which graph and things like that. Anyone need more time for this? Last slide today. So if you are, actually there's one more after that. If correct, well, if you're a scientist, you publish. You publish your findings. You want the world to know about it because you want to be the person to discover it. I mean, in case in history, we have something called Faraday's law of electromagnetic induction. Faraday's law. For the guy who invented Faraday. Well, there was another guy, he was a British guy. There was a guy named Henry. And Henry, that was his last name, was doing the same experiments that Faraday was. He was American. And they were doing it at the same time, but Faraday published first. So we call it Faraday's law, not Henry's law. So because Faraday published his findings first, even though they were really doing the same thing. Didn't know the other person was doing it, because they lived, one was in the United States and one was in England. Although Henry had his own set of discoveries, we do have things that we name after Henry also on that. So it's correct. We redo then probably even before you publish, you've got to redo your experiment because sometimes you do it once, it works, and after you do that, you can't get it to work again. Or maybe what did you do wrong? Look at the next step. If you're incorrect, was the experiment testing the hypothesis? Was the hypothesis correct for this problem? I mean, first of all, you have to ask, was I really testing what I think I was testing? And if you were, something's just wrong. Right or wrong? Which do you think has happened more times in history? Wrong. Yeah, a lot more wrongs than rights. Okay, so don't think because you get something wrong. I mean, you're in a vast good stead. I mean, think about Thomas Edison. How many light bulbs do you think he had to make before he got one that worked? Thousands. He used thousands of light bulbs before he got one to work. Yeah. Things like that. All right. Any more time on this slide? A little bit. All right. So again, and then once you finish, you reevaluate. Now, once we do all this, and guys, you don't have to write down the blue part. The blue part's just kind of an aside. So the red part you put down in your notes. Okay, once we finish all these steps, then we start thinking about laws and theories and things like that. And next time, we're going to finish up. We're going to talk about the difference between laws and theories and things like that. Okay? So, what you want to do in your labs. Now, so first of all, for your notes, for today's notes, we're going to make a summary. So you're going to make your quick summary, 3-line, your paragraph, 3 or more sentences on what we covered today in our notes. Then, you're going to get your lab. You're going to put those away. You're going to take your lab. And you're going to write your conclusion. Now, if you look in this lab report form, you notice in the form, there are a whole bunch of things. You read through here. First of all, you restate the problem. It could be done as a question, or you could, however you want to do that. Talk about those results. Look at the sample to give you an idea. Talk about the hypothesis. You talk about errors. What errors should be done. Explain your errors. And the more detail you have, the better. Talk about further study. Further study, further study. You don't explain how to do it. You say, a further study from this could be this. Everyday connections. Everyday connections on that. Okay? And you write your conclusion. Now there is this thing that has little prompts. So writing conclusion. Basically each part, every one of those statements, it gives kind of a little start of a sentence to help you write that. So take a look at that. And again, the sample. Now remember, you guys have been working together up to this point. We get to the conclusion, your work. Notice the biggest chunk of points is the conclusion. Because it's your work, your conclusion. Okay, so you work together at this point. At this point, you write your own. You write your own, calculate. And remember, the more detail you put in now, the less you have to rewrite later. The more you do now, the less you have to rewrite next time. Okay? On that, so everybody understand what we're doing for the rest of the period. So once you finish your lab, put it in the box. Find something to do quietly on that. Okay? Questions? All right, let's get to work. Now remember, short day, we got 12:05. If we all get done, we'll see else where we can go.